Suppose we have this kind of format in our integral with a square and x square. The other possibility is we may have x square minus a square and root of x square minus a square. This is one possibility. This is one possibility. And the other possibility is we have a square minus x square as well, because both are different, right? Here a root of a square minus x square. When these type of things present in our integral, we need to do some substitutions. Okay, we'll evaluate these integrals. Later we'll take them as the formulas. Okay. Now here, look at this. Do you remember any identity that is of the form? It is 1 plus some particular trigonometric identity square, like 1 plus tan square theta, like we have one formula, right? Is it? Likewise, 1 plus cot square theta, like one identity is there, right? So here in place of x, we can substitute either a tan theta. The substitutions for this, either a tan theta or a cot theta, like we can substitute. Okay, and then here you remember any identities of the form, some particular trigonometric ratio minus 1, like any particular formula you remember? You remember any particular formula like that? Secant square theta minus 1, remember? Is it? Secant square theta minus 1 and cosec square theta minus 1. So here the possible substitution should be a secant theta or a cosecant theta. You don't need to memorize this, simply find the identity like that. Now last chance, 1 minus some particular trigonometric ratio, that like, what's up? Sin square theta, that is a sin theta or a cos theta, like we can substitute them. Okay. Also we can relate them with the other formula, like we already have a formula for integral 1 by 1 plus x square dx, don't we? What is the formula for that? It is. Then what do you think about the value of integral 1 by a square plus x square? Could be related to this like one only. Okay, we have to figure it out what it is. So here when you see the denominator, what substitution is suitable is here. As you know, you don't need to memorize, simply check. Yeah, so we can substitute x is equal to a tan theta. Okay, then when we substitute x is equal to a tan theta, what you can say about dx, derivative of it, because we are going to convert everything in terms of theta. Substitution, that is how it works. Previously we have seen, remember? Yes. So a is a constant, we will keep it as a. Derivative of tan theta is what? Secant square theta. Derivative I am talking about. And then we have what dx is equal to a secant square theta d theta. What you can say about the secant square theta in terms of tan? Okay, first let us substitute and then we will decide. Okay, so here how it will become integral, instead of dx we got a secant square theta d theta divided by, here a square is there, right? A square plus, instead of x what we substituted, a tan theta, right? So that is a square tan square theta. Now from these two, a square can be taken out. Is it possible? So we have a secant square theta d theta divided by a square taken out. So 1 plus tan square theta. So a square and a will get cancelled. We have secant square theta divided by secant square theta. Secant square theta. 1 plus tan square theta is what again? Okay, these two also gets cancelled. So we have integral d theta and we have zeros in it. integral of a constant, integral d theta, what it is? This can be considered as x power 0, okay? Oh, sorry, theta power 0. And x power n formula can be applied. That's it. Yes, 1 by a is still there. We are having 1 by a integral d theta, and we have 1 by a theta plus c. What's our theta, girl? Yeah, tan inverse of x by a. Alright. Now, can you guess what about this one? Integral dx by root of x square plus a square dx. Shall I erase this? Integral dx by root of a square plus x square or x square plus a square. What could be the possible substitution for this? A tan theta, shall we substitute again? Then when we substitute, x is equal to a tan theta. A cot theta also you can substitute, not a problem, but I am substituting a tan theta. And then here dx by d theta is how much? A into secant square theta, and we have dx is equal to a secant square theta d theta. Now we can substitute it here. When we substitute it here, what we may get is integral dx by root of x square plus a square. It was given. Now it's been converted as a secant square theta d theta divided by root of x square, that means a tan square theta, a square tan square theta plus a square. And then we'll take a square as common from here. When we take a square as common, we get a secant square theta divided by root of like a taken out common, a will come out, we'll be having 1 plus tan square theta d theta. Alright. Then a and a will get cancelled, and we have integral secant square theta divided by, this is secant square theta, so root of secant square theta we get only secant theta d theta. So these two will get simplified, right? When I simplified, integral secant theta d theta we may get. What is the formula for secant theta d theta, girl? The integral of secant theta, you know. I say, see, log of secant theta plus tan theta plus c. Right. Now here in terms of theta we have to substitute. What could be written? This is what? Nothing but tan theta, what we substituted over there? X, right? So log of tan theta is x, secant theta is root of 1 plus, because tan theta only we have, root of 1 plus tan square theta. So 1 plus tan square theta means here no, x by a whole square. Alright, because tan theta is what? X by a. Now when we simplify it, then what we may get is, shall I erase this one? Now we may get is not integral, this one log of x plus the root of, this can be cross multiplied, right? A square plus x square divided by a plus c. So that is nothing but log of ax plus root of a square plus x square minus log a plus c. Like we can write. Why? Because log of m by n formula. Okay. And then this all together we can take it as one constant. So log of ax plus root of a square plus x square plus c. Okay. Any doubts on this? Oh, sorry. See, tan theta is not x girl, it's x by a. Then here also an x by a will come. Here no need of x. This is the final answer. Okay. So this like we can do integration for all these types and we can find their answer. Shall I erase them? I'll give you one small idea, based on that we can work. See, look at here. You suppose we have integral dx by x square minus a square and integral dx by root of x square minus a square and integral dx by, not dx by, let it be directly root of x square minus a square into dx, and then integral dx by 1 by a square minus x square into dx, and then integral 1 by root of a square minus x square. All these things look similar, aren't they? Or simply integral all the possible combinations I wrote now. Root of a square minus x square alone separately. Then how we can do? Same thing. The mentioned substitutions can be done and we can evaluate, but this is not possible all the time. So we'll memorize them as a formula. Okay. And look at here. Here dx by x square minus a square, the formula is 1 by 2a log of x minus a by x plus a. Okay. And then plus c. Suppose here this we can relate it with the known formula. Okay, we already know one formula, right? Dx by root of x square plus a square, one formula we know. What it is? Log of, now only we substitute, right? X plus something will come. Same like here also, x plus root of x square minus a square plus c. Alright. And then here, root of x square minus a square. This follows the format that x by 2 into what we substituted, that is root of a square minus x square minus a square, and then plus a by 2 into, if this comes in the denominator, what we are supposed to do? That formula, log of x plus root of x square minus a square plus c. And then here a square minus x square, these two has same kind of formula, but there is slight difference. 1 by 2a log of, here x minus a by x plus a, right? When the x gets negative, we get x plus a divided by a minus x. That means a plus x by a minus x, like we can remember. And then here root of a square minus x square. What is the formula for integral root of 1 by root of 1 minus x square? What is the formula this one? Root of 1 minus x square, girl, dx by root of 1 minus x square. Sin inverse of x, is it? And this is sin inverse of x by a. Okay. And there, this comes in the numerator. Then what is the format, you know? X by 2 into whatever is inside root of a square minus x square plus a by 2. Sorry, it's a square by 2. Here also made a mistake. A square by 2 into log of. If this comes in the denominator, what is the formula? That formula. That is x plus root of a square minus x square plus c. The same way, for this formula also you can write, that is integral root of x square minus, a square minus x square. Oh, wait a minute. X square minus a square only, like that. A square minus x square means what is the formula when it comes in the denominator, girl? Sin inverse of h by a, that alone will come. Okay. And then the any other possibilities which I left? Root of x square minus a square. Separately, in the numerator, square root of x square minus a square dx. Then what is the format? It is x by 2 into what we substituted plus a square by 2 into, suppose this comes in the denominator, what we are supposed to write? That formula. So that is log of x plus root of x square minus a square plus. Alright. And all this can be evaluated based on the substitutions we have discussed before. Okay. It is not possible, that is why we are relating them as a formula, and again I am saying it is like somewhat confusing. Is it? So we should write and practice all these things without getting confused, because suppose one formula if you differently substituted means the whole problem will get wrong answer. Okay. Simply if you ignore a negative also, it's a twisting question. Twisting in the sense arm twisting kind of questions. So all the possible combinations and some formulas you can easily relate with them. Like here this formula and all, which I related with 1 minus. Okay. Likewise this formula also we can relate with the 1 minus, x square minus 1. We have the same formula, right? We already studied those formulas. You can remember them and write. And except for only tan inverse of x by a formula only has 1 by a in front of it. All the other formulas are same only. Alright. Any doubts?